Hello everybody, Tara Peschel here with my last video. The class I chose for this project was my Algebra 2. Since quadratics have so many applications and are prevalent on the 11th grade MCA, I want to find better ways to educate my students on the topic of quadratics. In the chapter our textbook provides, we start by reviewing what a quadratic is, how to graph it by finding vertex, line of symmetry, and using a table. Next, the chapter reviews transformations with quadratics and shows vertex form and how to use transformations to graph quadratics. The next several sections of the chapter expands their knowledge of quadratics by teaching 4 different algorithms to find the zeros and also the background concepts necessary to understand the 4 algorithms, which are factoring, square root method, completing the square, and quadratic formula. Finally, the chapter introduces inequalities with quadratics and how to graph those. In my project 1, I identified 3 different concepts within this chapter that I want to focus more problem-solving processes on. And so the activity I have created for this video addresses one of those. My final project will include 2 other activities from this chapter as well. The concept I'm addressing is for this activity is solving quadratic equations. In the past, I have found that many students are relatively successful in using each algorithm when directly prompted, but when asked to solve a quadratic in general, they struggle with deciding which algorithm to use. In fact, most students don't have a clue as to which algorithm would work better for one versus another equation. In the past, after students learn the mechanics of each method, we would spend a class hour solving quadratics where the students get to decide which method they want to use for each quadratic. It seems to me that they spend the majority of the hour trying to use the method they most prefer or like or are comfortable with and wonder why it doesn't work for some and not others. I want my students to be able to look at a quadratic and analyze it to determine what would be the best way to solve it. So the minimal level of mastery I expect is for each student to be able to successfully use each algorithm to solve a quadratic equation. In essence, to correctly apply each algorithm to find solutions. Some of the challenges I see the students having include not taking the time to look at each problem and think about what characteristics the problem has. For example, how many terms does the quadratic have? Does it have a linear term in it? Is there a coefficient on the squared term? In addition, many students will start an algorithm to solve a quadratic and get lost somewhere in the middle. I don't think the students are using any metacognition to be aware of what they're doing and determining if the steps they're taking are making sense or not. One aspirational goal I have for my students is to be able to look at a quadratic and determine which method of solving would be the most effective to use. With that, another goal I have is that the students understand the pros and cons of each particular method. So, my lesson, I would give the students a worksheet and start with listing the 4 methods of solving quadratics, maybe writing a little notation to remind them which is which. We call factoring multiplies to, adds to. We could write down the quadratic formula, but have those listed at the top of our paper. And then I would give them 4 quadratics. We're going to make a pro and con list for each one. So for each example, list which methods would work well and which wouldn't work well and why. So taking a look at number 1 and saying, okay, of the 4 methods, which ones would work well for that and why, which ones wouldn't. So hopefully in their groups, and they'd be doing this in their groups. I have pods in my classroom with desks in groups of 4. You know, they would look at that and they know all of them can use quadratic formula, but it can be cumbersome. When is it better to use quadratic formula and when is it better to use something else? So for example, in number 1, factoring may work well if we can find a combination that multiplies to -10 and adds to -3. Factoring is also nice here because there's nothing in front of the squared term and we don't have to do a longer process for factoring. In addition, number 1 wouldn't work well for completing the square because identifying that the middle term is odd, and if we have to take half the middle and square it, we're going to end up with fractions and decimals, and those get ugly as well. So they would continue and do that for each one, and then we would come together as a group and talk about, okay, what are the pro algorithms for number 1, why would they work well, which ones wouldn't work well, okay, and do the same for 2, 3, and 4. Hopefully we get all of the groups participating and understanding what key characteristics would help for which algorithm. Once that's done, then we would go to the homework part, and usually they have time in class to work, so they'd be working on these together. And so on the back of that worksheet are going to be the 4 quadratics that we used to make the pro-con list. So they would actually solve those 4, and in additional, there would be 4 more underneath. So they would solve a total of 8. And in their groups, they could take a look at them and decide, okay, which ones are we going to use? I'm hoping that this would take 1 class day. In my final project, before I would do this activity, I hope to do one that works more with the graphing, because I think kids struggle a lot with graphing quadratics. They make errors in computations when they're doing tables. If they are in vertex form, they can use transformations easier than calculating tables. So being able to identify, again, taking a look at it, what would be the easiest method to use to graph them? And then finally, for my last activity that I'll be doing in my final project is at the end of the chapter, taking a day and applying everything we've learned in the chapter to solving real-life application problems from physics or other areas, because there's so many applications of quadratics. So, thank you.